Good afternoon, good morning, and good evening. It's Way T Lightheart here today with co-founder Matt Gallant and a super special guest, Dr. Dominic D'Agostino. I have been, hoping for this interview for a long time. For those who don't know who Dominic D'Agostino is, he is one of the preeminent experts on ketogenic diets and ketosis. He works with the Navy SEALs and a variety of projects that he's done that are heavily research oriented, and the benefits that this potential dietary practice can have both in performance applications as well as physical health issues, related to cancer, things like that, cognitive function, a bunch of different things. Dom is a professor at the Department of Molecular Pharmacology and Physiology at the University of South Florida, and a research scientist at the Institute for Human and Machine Cognition. His laboratory develops and tests metabolically based strategies for neurological disorders, cancer, and for enhancing the safety and resilience of military personnel in extreme environments. His research is supported by the Office of Naval Research, Department of Defense, private organizations, and foundations. He just recently came back from a trip from Australia where he was speaking literally in 5 cities in 11 days. And he was gracious enough to take the time to join us on the Awesome Health podcast. So delighted to have you here. Dom, welcome to the show.
Great to be here. Thanks for having me, Matt. And Wade.
And as much as Wade's excited, I'm even more excited. I've been a fan of your work since I think I first heard you probably, I think, on the Tim Ferriss podcast, which was very enlightening. And I've been a long time keto user and dieter for 26 years on and off, nonstop now for 4.5. And at Bioptimizers, we have this three-sided triangle of, aesthetics, how we look, the performance and the health side. And I think you're one of the top guys in the world to talk about the performance side and the health side of keto, because most people talk more about the aesthetics, the fat loss, and that component. But today I'd really like to dive into, maybe we could start with some of your background and what you've been doing research-wise, and then we can get really into all of the current stuff you're doing around performance and health. So maybe give us a little bit of background as far as what you've been up to the last 5-10 years as far as keto research.
Yeah, for 10 years, well, just quickly going back to 25 years ago, I was always interested in nutrition, and I majored actually as an undergrad in nutrition sciences and dietetics. And as I navigated my college career, I realized that there wasn't a whole lot of jobs in nutrition. So I kind of moved to majoring in biology too. And then I did my PhD actually in neuroscience. And when I finished my PhD, I was funded by the Office of Navy Research for my fellowship, postdoctoral fellowship. And that was really to understand oxygen toxicity seizures as it pertains to the Navy SEAL diver that's using a closed circuit rebreather that they use for operational conditions. There's a stealth component to this equipment. There's no bubbles when you dive underwater. A disadvantage would be that you're breathing high oxygen, 100% actually, with the certain type of rebreather. And it's just 50 feet of seawater, you can have a seizure within 10 minutes. Some people, can have that, and there's really no way to predict or prevent them. So the first area of my research was developing different technologies that would allow us to understand sort of how the brain was working under these conditions. And if you understand the problem, then you can come up with a solution. But we didn't fundamentally understand the problem. So we developed things like microscopes and electrophysiology equipment and telemetry equipment, and we adapted that for use inside a hyperbaric chamber. And then over, 5 or 6 years, I started to realize that targeting brain energy metabolism and the neuropharmacology of the brain are two strategies to protect the brain under these extreme conditions. And I was sort of interested in antioxidants. Loading up animals with antioxidants really did not seem to work much, although in theory it should have. But then I started moving towards like coaxing our own bodies to being more resilient. And there was some studies that was done fasting rats for 24 to 36 hours. And that actually had a remarkable effect at preventing these seizures. And it was actually greater neuroprotection than the anti-seizure drugs. So I became interested in how fasting could mitigate and be a mitigation strategy or countermeasure against these types of seizures. And then discovered the ketogenic diet, which I sort of thought I knew, but I really didn't know the whole history of the ketogenic diet. You know, growing up, you hear about low carb diets, Atkins diets, and you know, I had been interested in the zone diet at one point and a low carb a little bit, and I did it kind of on and off for different years. But when I delved into the history of the ketogenic diet and met with the practitioners at major universities, like especially Johns Hopkins group, I realized that this could potentially be, I could incorporate nutrition back into my research program and do sort of like a nutritional neuroscience project. I would just have to convince my program officer at the Department of Defense or Navy that, you know, this was a good strategy. And the science was actually there, like on PubMed, you know, I mean, there was good peer-reviewed studies showing that independent of the etiology, independent of the cause of the seizures, the ketogenic diet seemed to help across the board. So, and oxygen toxicity seizures are powerful tonic-clonic seizures we think are being generated in the hippocampus, which was an area that I was studying and published on, and also maybe influencing the neural control of autonomic regulation, and actually did my PhD on respiratory neurobiology, brain science. So I had a sort of an understanding of sort of what was happening and a new understanding and appreciation for nutrition as a metabolic therapy. And I was never taught anything about the ketogenic diet through my 4 years of training and two semesters actually of advanced nutrition and graduate nutrition. Never even heard about the ketogenic diet being used. And it was like the standard of care for drug refractory epilepsy. So long story short, the dietary approach it didn't really grab the attention of the program officers. They wanted to see a ketogenic diet sort of in a drug. So I went down the path personally from a research perspective of just studying ketones and different formulations of ketones. But I also started doing the ketogenic diet myself to understand it from the implementation perspective. People weren't doing the ketogenic diet, the clinical ketogenic diet back when I started in maybe 2008, 7 or 8. But as I followed it, I realized after I got through the initial adaptation, I felt really good. And I prior to this, my meal frequency was 5 or 6 meals a day. And I transitioned actually to eating less often to the point where I adapted to doing intermittent fasting occasionally once in a while. And then as we developed various ketone technologies, including ketone esters and ketone electrolyte preparations mixed with MCT, and started studying it, we realized that these are very powerful neuroprotective compounds that have a wide range of applications, not just oxygen toxicity seizures, but different metabolic disorders are highly responsive to nutritional ketosis. Some are the standard of care, or the ketogenic diet, I should say, is the standard of care for things like metabolic disorders, like glucose transporter deficiency, pyruvate dehydrogenase deficiency complex. We study Kabuki syndrome, which is a genetic disease, and we look at the role of ketone bodies as an epigenetic regulator, activating some genes and silencing others that can impart their therapeutic effects. So, and then cancer too is another area. I've had 3 PhD students graduate under me, training under me, that actually focused on looking at the ketogenic diet to impact the growth and proliferation of cancer. Metastatic cancer, we're looking at cancer cachexia, which is muscle wasting associated with cancer. We're also looking at drugs like metformin and other metabolic drugs that sort of target different pathways that overlap with the ketogenic diet. So I started studying it for something that was relatively esoteric to most people, oxygen toxicity seizures, and now we now we're studying, I would say probably close to a dozen different things, including glucose regulation, everything from ALS to Angelman syndrome to Alzheimer's disease, Kabuki syndrome, glucose transporter syndrome, a number of other kind of even more rare things that you may have not heard of. And we're also, developing forms of ketogenic compounds, diets, and also supplements that would allow the warfighter and potentially even the astronaut to implement some form of ketogenic nutrition to enhance performance and resilience in extreme environments. So going back to the Navy project, I've continued to be funded by them, for like almost 12 to 13 years now. And I continue to have projects, and we've developed the animal work, and now we're actually doing studies in humans. And now we've actually moved on to working with NASA, where we do experiments where we live in an undersea environment for an extended period of time in what's called saturation. And when you're in saturation, it takes a long time to decompress and to come up. So your body is in an extreme environment, not just pressure, but higher ATA of oxygen, higher partial pressure of carbon dioxide too, which has an effect. So we have projects where I look at the gut microbiome, psychological testing, body composition. We look at a number of other factors, that are influenced, in these extreme environments. A lot of like psychological, what we call team building or cognitive team cognition. So how the group works together, and that can be impacted by our energy state, our metabolism, our neuropharmacology. So we're looking at a whole suite of parameters of people in these environments. So we figure out where the decrement is. And then once we understand that, then we develop sort of a lifestyle, which is my focus is nutrition and supplementation, to basically enhance, resilience in that environment. And that would be physiological resilience and psychological resilience. So we're putting a lot of time and effort into that project now.
Yeah, no, I just wanted to comment on that. And one of the things I think from a practical standpoint that I think people can relate to, and I'm curious about this one because I think I was listening to you on Tim Ferriss, you had gone an extended period of time of fasting and were able to do a ridiculous deadlift set. Do you want to talk about that just briefly? Because it's just a curiosity component of, I heard about it. I want to be confirmed that I heard it correctly. So I'll let you speak from the horse, because what it seems like you've been able to do is something that almost no one would believe possible.
Well, I don't think fasting or being I don't think the ketogenic diet, some people think the ketogenic diet will dramatically impair your strength and performance. And once you're adapted, I don't see that as being necessarily a problem if you have protein, equate for protein and total calories. So fasting's sort of like another thing, but also kind of similar. In a fasting state, after about the second or third day, it gets hard around that time. But once your body adapts, you actually feel better. Your energy level starts to get a little bit low towards day 5 or day 7 in me. I haven't went beyond a 7-day fast. And I realized that, I wouldn't want to do a high volume workout during that time, but I realized that my overall strength, just by how I felt, really was not impaired much. And I just wanted to, kind of feel how the weight felt on my body. And actually my inflammation was gone. I felt good in so many ways that I just kept adding weight, 135, 225, 315, 405, and 405 felt easier than I expected. So I was like, okay, let me try 5 plates. And I did 5. And I was thinking maybe I should stop there. My body's sort of in a low energy state. And I just kept going. I normally can do more, but I felt that the 10, I don't even think I got sore the next day. But yesterday, actually, I got back from traveling in Australia, and I picked up a stomach bug on the last day. So I really didn't eat for about 2 or 3 days. And yesterday, I just posted it on Instagram and Facebook. I deadlifted 5 plates for 15. and my body weight was really low. It's 198. That's extremely low for me. I haven't been that low since I was a teenager. And I was kind of in a fasted state again. And again, I don't, for exercises, like for things, pressing movements, if I lose weight, my strength goes way down. But for things like deadlift, I always kind of feel strong in a semi-fasted state. And I think I'd mentioned this to Tim's friend, and Tim's friend told Tim, and then he unexpectedly added it to that podcast. And I was like, no, don't add that. He's like, no, I think you got to start off. That's how you engage people. So I requested it, he not mentioned that, but he mentioned it. And it's like, then I had to live up to it. Then I had to actually go and do it.
But well, it's a fascinating segue, because it's a pattern interrupt for most people who think if they go on 3 or 4 hours without eating, they're going to die, especially
I was in that
bodybuilding 6 times a day. Yeah, exactly. So it's a point of interest, I think, that kind of, creates another level of curiosity for people to find out, well, how is that possible? What is this guy doing? I think it just adds a level of verification about the efficacy of what you're doing and what you're promoting and how you're going about doing it. It also opens a door, I think, which Matt's going to dive into here, about asking some very specific questions, because as he'll reveal, he's been deep down the ketogenic adventure for as long as anybody I know.
Yeah, it sounds like longer than me, I think.
Yeah, so I want to get into I guess some nerdy stuff, and one of the things I believe, and I'm curious what your thoughts are on this one, Dom, is that if we look at health as a spectrum, on one side you got sickness, and then death, and then in the middle is what people call normal, and then at the very end of the other side you have peak performance, peak health. So what I've seemed to notice is that all the things that might fix health issues, that get us from sickness to normal, will typically also get us from normal to a peak state. And I want to get into the neurocognitive enhancements that happened with the ketogenic side, and I really want to understand what's happening exactly, again, on a brain level and on a nervous system level, that is producing enhancements. Like why is ketones enhancing the cognitive side?
Yeah, that's a subject of intense research in numerous labs right now. We have garnered sort of a lot of information over the years, personally doing it myself and actually measuring my neurotransmitters and other blood markers of metabolic health and inflammatory health and neuroinflammation.
So can I ask you, what have you seen on a neurotransmitter level?
Yeah, and what tests are you running, and that because I think that's great data for point.
Yeah, I have different kits here in my drawers. I was going to show that for neurotransmitters, it's not a great test, but one of them that I did, and I did a couple, ZRT Labs has a urine neurotransmitter test. And I think when I did it down inside the habitat for the NASA NEMO mission, a couple of them for some reason didn't come out, but the things that came out made a lot of sense. I've done repeated measurements, and my GABA to glutamate ratio is very high. It's on the order of 2 to 3 times outside the range of normal. So I tend to, at least in a ketogenic state, you make the neurotransmitter gamma aminobutyric acid, GABA. It's a brain stabilizing neurotransmitter. You actually make that from an excitatory neurotransmitter called glutamate through an enzyme called glutamic acid decarboxylase. And being in a state of nutritional ketosis with the diet, and now we know with supplementation, activates the GAD enzyme to convert more glutamate to GABA. So you go from a state of the brain that's hyperactive in the context of what we study. There's excitotoxicity, glutamate excitotoxicity. And I think it's in part therapeutic because you are reducing a neurotransmitter that's causing neuronal hyperexcitability and making GABA, which I don't want to get too down the weeds, but it does chloride mediated postsynaptic inhibition, which it opens up an ion channel that hyperpolarizes the membrane potential of the cell. And when a membrane potential is hyperpolarized, it doesn't fire action potentials as fast. It's very stabilized. And if there's lots of glutamate excitatory, that will depolarize the membrane potential, and it comes closer to its threshold for firing. So it starts firing action potentials very fast. And if all your neurons are doing that, then you're like dumping glutamate, you're dumping potassium, you're dumping calcium potentially. And this can create a scenario where you have excitotoxicity. So in a nutshell, what being in nutritional ketosis does is it changes the neuropharmacology of your brain to prevent you from entering that hyperexcitable state. And so that's one of about a dozen things. And I could go down the sort of a list about it on a dozen different things.
No, but that's fascinating, because I've done some tests and I'm on the slightly deficient side of GABA. So it's probably one of the reasons why I love keto in general, and why I respond well. So I did not know what you just revealed. That's fascinating.
Yeah, we've published that too, actually. And well, it's been published in humans, but we did it in a model of Angelman syndrome. And we actually have an Angelman syndrome clinical trial at Vanderbilt right now because of some of the work that we did in preclinical models.
So one question, one obviously common belief is that the brain runs on glucose. What's your answer to people that believe that?
Well, that's what I was taught. That was part of my training in nutrition. You never go below 60 grams of glucose because that's what the brain's obligate requirement. But then because I got interested in fasting, I was thinking, well, like what does happen when you fast? And I was thinking, how can people fast and not go hypoglycemic? And then I started reading the work of Dr. George Cahill from Harvard Medical School, where he fasted subjects for 40 days. Towards the end of that, he injected them with insulin to push their glucose down farther. And it revealed that they were asymptomatic for hypoglycemia because the fat that their bodies or adipose was releasing for energy could be used by skeletal muscle in the heart. The brain really doesn't use these large fat molecules for fuel because of the blood-brain barrier. So the liver converts them to small water-soluble fat molecules we call ketone bodies, or fat-derived molecules. And then the ketone bodies can largely replace glucose as an energy source. Although our blood glucose levels, there's very powerful homeostatic mechanisms that maintain our blood glucose levels. So glucose really doesn't change all that much. It'll go down to like maybe 3 millimolar or something like that. The glycerol backbone of triglycerides will continue to make glucose. And then you have gluconeogenic amino acids, especially alanine, that gets released from muscle tissues, and that can become glucose. But the primary fuel for brain energy metabolism can switch from glucose to ketone bodies. And I say primary fuel because more than 50% of brain energy metabolism, it's kind of universally agreed that after prolonged fasting that we are using primarily ketones. And the same thing can happen with a strict clinical ketogenic diet. You're primarily running the brain off ketone bodies.
So just to recap, your body has a lot of different ways to internally produce glucose, which is kind of a fascinating thing. Because I've noticed that too, that even when I'm, zero carbs, carnivore, or fasting, that, my blood glucose might drop as, high 70s, but it's hard for me to go lower than that, even if I'm zero carb and fasting and whatnot. So, yeah. Have you noticed too that the longer, and I've seen some interesting research recently on this, that if you've been on keto for a long time, that there seems to be another level of adaptation where even while you're exercising, the glucose is staying in the muscle. Like the body's actually not even, touching some of the glucose. Because I've noticed that even in the last year or so, that I just seem to be holding on to more glycogen in the muscle than I used to, even when I'm doing all the same things.
Yeah.
Did you notice that?
Yeah. That'll be dependent to some extent on calories. So if calories are if you're eucaloric and you're not at a calorie deficit, actually, well, I'll come to that later. But if you do become at a calorie deficit and you're carb dependent, you lose glycogen really fast. If you do become calorie deficit and you're adapted to a ketogenic diet, you lose glycogen much slower because you are using fat for energy, or more fat. The ratio of fat is higher than the ratio of glucose you're using. So, but yes, I think Jeff Volek has published on this too in athletes, is that skeletal muscle glycogen, not liver glycogen, but skeletal muscle glycogen does not change that much in athletes that are extremely carbohydrate restrictive with their diets, which is difficult for some people to believe. But once you understand metabolic physiology and that we have adapted the skeletal muscle, the primary engine, that's burning the substrate, to using fatty acids for fuel, that actually has a glucose sparing effect. And the glucose sparing effect, because you're using more fats as opposed to glucose, will preserve muscle glycogen over time. There becomes a tipping point, and I think everybody's a little bit different, but I think the point is that athletes that are adapted to nutritional ketosis really do have a remarkable ability to retain muscle glycogen.
So one of the big concerns that some people have, and I know Wade had this concern as well, is the loss in kind of, let's just call it the last 10%, like that peak, especially if you're more of a power athlete. What's your opinion on that? Is that something that if you're fat adapted for long enough that you can regain? What have you seen as far as peak performance, again, from a kind of a either peak sprinting, weightlifting, those type of athletic endeavors?
Yeah, these are really good questions. I do believe I've seen enough data to suggest that if you are on a very carbohydrate restricted ketogenic diet and you push an athlete to these extreme short bursts of output, total power output may be compromised, will likely be compromised to some degree if someone's on a very restrictive ketogenic diet. If you don't add carbohydrates in. So I think, there's a lot of nuances here, but I think that if you take the average athlete who's carbohydrate adapted and adapt them to a low carbohydrate diet, forcing their body to sort of burn preferentially more fat for fuel, they can get 80 to 90% of the benefits of low carb without compromising their glycolytic capacity. And you can do this simply by titrating in the carbohydrates back into the diet. Low glycemic index carbohydrates, small amounts of carbohydrates will keep glycolytic pathways sort of open. Various enzyme systems like pyruvate dehydrogenase complex. So that enzyme, the people who favor high carb diets will say, well, your pyruvate dehydrogenase complex will be suppressed. You won't make as much protein, and that the enzyme itself won't be as active. I think one way to keep that energetic path open is to periodically add some carbohydrates in, maybe in and around your training, and that could be beneficial too. And also, if you are a low carb athlete, when you fuel up intra workout, the type of workouts I do, I don't really have to fuel up. If I work, my workouts are like 15, 20 minutes or something. But for athletes that work out for like hours at a time, to then introduce a sort of, a carb and a fat sort of supplement at the same time, like MCT oil, or maybe even mixed with some long chain fats, but also a slower burning carbohydrate source after a certain point, because you do get carbohydrate, it does become a limiting substrate under some conditions. And I think each person is a unique metabolic entity and needs to experiment. But like the take home message is that if you go on a super strict diet, your low end may be knocked down a little bit. But if you learn how to use carbohydrates as a performance enhancing substance and you use it sparingly, then I think you can get the best of both worlds from my perspective.
Yeah, I know some guys that have tested their ketones by doing some cyclical carb refeeds intra workout, and they've gone as high as like 80 grams on a leg day and had no changes. So they've been able to just maintain ketosis. And because obviously in a squat day, a big deadlift day, you're just going to be burning that glucose in real time.
And I mean, the keto community may like cringe at this, but I really believe that carbohydrates are a powerful performance enhancing sort of substrate if used strategically. And if you deliver certain types of carbs, I mean, it could be any kind of carb. I mean, when I experiment, I'll use chocolate. I mean, I'll use like stuff like that. So it doesn't really have to be a particular kind of carbohydrates. But if you add also lots of water and sodium too, while you're delivering the carbohydrates, your blood volume will go up. I mean, you'll notice things in the gym, the energy that you feel may just be due to the hyperhydration you get. And it doesn't take much. So that's the key. You don't have to throw in like 300-400 grams of carbs. I mean, it could be as little as 30 or 40 grams of carbs. If you're a really big guy doing a long workout, yeah, you might want to titrate, 80 grams of carbs over that duration and maybe a little bit with a refeed. But it certainly doesn't take a lot of carbs when you're talking about someone who's fat adapted. I mean, I think 30 grams of carbs for the typical, 1.5 hour workout, however long people work out these days. So.
And now for a Bioptimizers fixed digestion tip, rapid cheat meal relief. Research shows that cheat meals can actually be an effective way to boost your metabolism. One key weight loss hormone, leptin, can be increased by up to 30% following a cheat meal. The challenge with the cheat meals is that all those extra calories and lower food quality can be hard to digest, which means you could be totally sidelined with a food coma after big cheat meals. The solution is to take strong digestive enzymes like masszymes, which will help rapidly digest and break down the extra food. 3 to 5 capsules before or right after your cheat meal can make a huge difference in how you feel following the cheat meal. If it's a cheat day with multiple large meals, you might want to go up to 10 capsules or higher to help you power through all that food. To save 10% on masszymes, go to masszymes.com. That's MASSZYMES.com and enter the code CHEAT10 at checkout.
So you're really opening up a topic that I've had in my mind for a long time, which is the idea of dual fuel.
Yeah.
Right. So the idea that you can both run on glucose and ketones simultaneously. I mean, I've done it personally many times.
Yeah.
Can you, first of all, can we start with the physiology? Like how is that happening? How is the body burning both glucose and ketones at the same time?
Yeah, there does seem to be, like, it's a strange question for me, like someone who studies physiology, because I mean, it's just, that's what the body does. But I know there's 2 camps out there who just kind of believe that, we fuel off carbohydrates or we fuel off ketones and fats. But your body has, and your brain, we now know, has amazing metabolic flexibility. So if we adapt our bodies over time, and the best way to adapt is to train under specific metabolic conditions. So training while you're fasting periodically, I mean, some people cringe at that, but I think doing it occasionally is a good idea. Training in a state of nutritional ketosis, occasionally throwing carbohydrates in so your body recognizes that fuel, and to do that periodically. So, I mean, I'm coming at a neuroscience perspective because I believe a lot of our physical output and our brains are wired to our muscles. So if our central nervous system is energized and we have good fuel flow to it, it's going to fire muscles and contract more muscle fibers. So we can actually get stronger contractions and maintain that over longer periods of time. If we our brain has metabolic flexibility and will use whatever fuel is available. So glucose and ketone bodies, we know it can use lactate too, a little bit amino acids, but usually, glucose or ketones. So it will use whatever's available and whatever's in the blood. So one strategy could be to do a carbohydrate-based diet that's low enough that you maintain optimal insulin sensitivity, and then throw in ketogenic nutrition, which could be MCT oils or ketone supplements, without necessarily restricting carbohydrates to the point where you are in ketosis. MCT oils can achieve that, and also ketone supplements on the market can also achieve that. This is a new idea, but we do know that independent of carbohydrate restriction, if you administer a ketogenic agent, whether it's a ketone salts, even MCTs or ketone esters, the body will use what's available. So if you elevate that substrate. Interestingly, if your ketones are elevated, it seems to facilitate glucose disposal in the tissue too. Although it kind of appears like that because your blood glucose goes down when you administer acutely a ketogenic agent. Some individuals, some labs believe that that's an increase in insulin sensitivity that's facilitating glucose disposal. That could be happening, but I think when you orally administer a ketogenic compound through counter-regulatory mechanisms we don't quite understand, there's a decrease in hepatic gluconeogenesis, and thereby hepatic glucose output is reduced. We have not done the liver metabolomics to figure out what's going on, but it kind of makes sense that if the liver's, seeing a high concentration of ketone bodies, it's going to want to spare glucose. The glucose you have in your blood now is not like, it's the glucose that your liver regulates. So your liver is the master regulator of the glucose that your peripheral tissue sees. So the glucose that's in your blood now might be from a couple days ago, the glycogen that's stored in the liver a couple days ago. So your liver is like the master regulator. That's why it's important to keep the liver healthy. And when the liver sees ketones, I think that it's decreasing glucose output. This is important therapeutically for like type 2 diabetes, and also, but it's also kind of important too from a dual fuel perspective, which was the question. I think people will ask, well, what will happen if you throw ketones on top of glucose? Then you're creating this artificial scenario, which could be dangerous. But I believe that, well, we now have experimental data to show that the liver does a pretty good job at recognizing the level of ketones that you have and in utilizing those fuels. And people maybe look at exogenous ketones as this artificial fuel, but it's really just another energy source. I mean, you could say that with creatine, right? I mean, we make creatine, we store it a little bit, and when we drink it, we're getting super physiological levels. From the literature, all we can tell is it's doing positive things. And I think ketones are kind of like, it's good to make them through our own physiology because that forces adaptations, and adaptations are necessary for the ketogenesis process, the ketone transporter process going across biological membranes. And also, if the cells see ketones, you're also upregulating ketolytic enzymes, which allow cells to derive energy and ATP from the ketone molecules. And I think that happens faster when we do it naturally with the ketogenic diet or fasting. And then if you throw ketone supplements on, sparingly, I haven't used them today. I don't use them every day, but I think you can kind of game the system a little bit and gain an advantage. I mean, that's what our research shows.
I would echo that from just a clinical my own stuff. Matt, of course, has been on the ketogenic diet. I'm a plant-based guy, but I have an extraordinary blood insulin response, whether that's genetics or whatever. When I measure myself, I'm often in a ketogenic state almost when we do our typical fasting on a HOMO IR or that sort of stuff. But when I've added ketones, exogenous ketones that Matt's provided for me, I notice an instant cognitive performance benefit. Like, it's like, okay, I'm a little sharper, everything's a little crisper, and the endurance factor seems amplified for sure. So I would echo that, and that's not very scientific, but it's certainly experimental. And I'm curious, do you kind of do these experiments on your own and then start doing the data and kind of like hitting your biofeedback and then go, hey, let's dive into this and see if this is true, or I'm just projecting? Or is it you come up with a theory you do in the lab and then you go the other way? I'm kind of curious which way you like to process this.
Oh, that's a good question. It goes both ways sometimes. And when I got interested in fasting and I read the Cahill studies, then I was like, okay, I got to do this myself. I'm not going to do 40 days, but I'll do a week and see what happens and do the blood work and things like that. And basically all my health markers improved, kind of as you guys would expect. And and as we develop things in the lab, like synthetic ketogenic agents, we'll use them experimentally. And sometimes I, take a little myself through the years. And some of the things that we use are not, they're experimental compounds right now, but they are tracked towards clinical use. And once you tinker with these things, then you start to realize some of their potential, right? Their therapeutic potential, because some of them, like you can actually feel, quite remarkably with an acute administration, and it's not acting like a stimulant. It's not, you're not mixing it with caffeine. You're just elevating the level of available fuel that your brain sees, and that has an effect.
So I have a question on that, because
Yeah.
usually twice a year we go do some really extensive, hardcore, difficult brain training. It's about 6 hours a day of pushing your brain to its absolute limit. Be the equivalent of probably running a couple of marathons a day. I did the first couple of times without ketones, and then we started adding 30 to 60 grams of esters a day. And that allowed us to just continue training, because usually your brain started crashing by day 3, day 4, Wade and I have gone through that. But with the esters, there was no crash. Like day 4, day 5, day 6. I mean, you're kind of getting tired, but that's more of a nervous system, thing. But at the same time, we were able to continue the training. But the thing that really blew my mind, and I don't understand what's going on, was the recovery. It gave me a little more energy. But what I really noticed was, one, it seemed like I needed almost less sleep taking that many ketones, and that I just felt relatively fresh the next day, again, even despite pushing myself. So from a recovery standpoint, what's going on there?
Yeah, that's a good, interesting observation too. If you collected data on that, it would be good to put that together. I guess going back to the experience that I can draw off of, where I've quantified things to as much as possible, would be the NASA Extreme Environment Mission Operations 22, NEMO 22, where a lot of people think I use ketone supplements like every day, because we're kind of like the people who brought them to market. Me and like Patrick Arnold, actually, and years ago, and different companies are selling them now. But I don't use ketone supplements every day, but I did during that mission, especially doing the EVAs, the extravehicular activities and things like that, and from morning multi-dosing throughout the day. And I had experimented with in the past, and what I do consistently notice, getting back to recovery, is that if I'm in a state of deep ketosis, especially with exogenous ketones, I do tend to sleep a little bit less. Like lately I've been sleeping like 8 hours, sometimes 9 hours, but I could sleep about 6.5. And then my amount of deep and REM are the same. So the restorative sleep that I'm getting when my body is in a state of nutritional ketosis seems to be better. So if your brain has ketones available, we now know that the carbon backbone of those ketones are part of the biosynthetic process of making neurotransmitters. Like alpha ketoglutarate, for example, is the precursor to glutamate, is the precursor to GABA. So and this is called an anaplerotic pathway. So the tricarboxylic acid cycle, or the Krebs cycle, is a cycle of succinate, fumarate, malate, citrate. All these, we have demonstrated through metabolomics that these become elevated, and you are sort of driving the biosynthesis of neurotransmitters by virtue of increasing TCA cycle intermediates. So I believe that this is accelerated because you have the substrate available, you have more precursors to make neurotransmitters when you sleep. also, if you're in a state of ketosis, our astrocytes, so we have neurons and we have astrocytes, and there's other cells like oligodendrocytes and other, but if we just talk about, the two main cells, neurons and astrocytes, the astrocytes tend to store energy in the form of glycogen. When you're in a state of ketosis, the ketones will spare, just as it does sparing muscle glycogen, the ketones will spare the glycogen in the astrocytes. And part of the restorative process of sleep is to restore the glycogen levels in the astrocytes. So because you're using ketones, you don't have to kind of restore glycogen levels. So I think that's something. And also there's something called the glymphatic system. So your brain has a system that is activated. It's activated all the time, but more so when you sleep. And there are things, ketones can enhance brain blood flow by 30% when you acutely elevate ketones with like different ketogenic compounds. So I believe that increase in blood flow and other factors that are associated with ketosis will increase the glymphatic system performance, if you will. And we'll get, and this needs to be tested, it's just my speculation, is that you're enhancing astrocyte glycogen, neurotransmitter synthesis, and also the glymphatic activity while we sleep.
Makes sense about, sorry, go ahead, Wade.
That's a multi-day thing that you're doing. So you're looking at it. So sleep would be really important, it sounds like.
It's critical.
Yeah,
And we're running dual fuel during that time. So like I'll eat a little more carbs. So actually running dual fuel seems to help. The other thing that seems to help too is like I'm not a big branch chain amino guy, but adding aminos. So I'm taking 60 grams of ketones, taking like 20 grams of aminos, plus I'm eating carbs and a lot of good fats as well. And it just seems to help on all levels. So one question that I've had, and I haven't seen too much research on this, but experientially I've certainly noticed that. What have you seen in terms of the types of fats and their ketogenic response? Because for an example, like if I eat animal saturated fats and I measure my ketones, like especially like things like pig fat or lamb fat, it definitely seems to produce more ketones than monosaturated. Like just different fats seem to produce a different ketone response. What have you seen around that? And do you think that's important?
Yeah, so that's an ongoing question in the ketogenic diet. Well, it should have been ongoing for like 20 years, but only recently are they kind of recognizing that, different fats have different effects. It's not just like macronutrient profiles. And I think people have different food sensitivities. So some people who have a mild dairy allergy, if they take a dairy-based fat, the activation of the sympathetic nervous system or various immune factors may actually prevent ketone production. So I found that mildly in myself, but I kind of, going back to your observation, I think fat in the form of butter, meat fat like pork fat, beef fat, to some extent, maybe chicken fat. These all contribute to very stable, predictable ketone production in meat. And when I try to sort of mimic that with more of a plant-based, I can get my ketones elevated, but it's a little bit less predictable. But I think that's primarily because of sort of the plants that I'm getting the fat from, like nuts, like macadamia nuts and almonds and avocados. You're delivering fiber with it too. So sometimes I can get my ketone elevated to the same extent. And sometimes I think because the natural fibers that are in plants are maybe preventing the release of the fat and it's going through me. I know if I eat like a lot of raw almonds or something like that, I'm definitely not absorbing all those fats, so if I eat an equivalent amount of fat from raw almonds as opposed to pig fat, and I acutely do it. I eat the meal and then measure fat later. Your ketone production will be like proportional to the amount of fat that the liver is seeing, dietary fat. So it's kind of hard to quantify that. I guess you could use plant oils and things like that, but
it seemed, of course, there's the nutrigenomic aspect, which there's certain genes that obviously seem to indicate better saturated fat breakdown and so on and so forth. So there's probably a pretty strong genetic component to that question.
Absolutely. And, I would like to know more about that, and I try to keep up on that as much as possible. I have my own 23andMe data, and just looking at, putting it on different platforms. I kind of know what works for me just through experientially. And I know some people have, they have different SNPs that prevent them from metabolizing fatty acids as efficiently as possible. And it may not be an on or off kind of thing, but on a spectrum, right? And some people are just poor oxidizers, poor metabolizers of fat. So they will, if they eat a high fat diet of animal fat, they feel sick. They don't feel good. And their triglycerides go up. And then it doesn't come down over time. And I would tell that person, don't do an animal-based, and some people feel really good on a plant-based diet, and all their health markers improve. And, I don't know if they give the ketogenic diet enough time, but because your body does need to adapt to that over time. But I'm not one or the other, but actually I probably eat an enormous amount of plants and I have lots of, and I do believe that they should sort of be in the raw form as much as possible. A lot of broccoli, asparagus, cauliflower, things like that, and a big salad pretty much every day. And then I add a fatty beef, chicken, or a lot of fish. We tend to eat a lot of fish in our house to that salad typically. And then maybe add oil on top of that in the form of avocado oil, macadamia nut oil, olive oil. And then I mix MCT oil with the salad dressings too. So I find that's the optimal way to get my ketones as high as possible.
I mean, Wade is the king of the best salad. He is.
Yeah, salad,
yeah. Wade introduced me to that like 20 years ago when we were both living in Vancouver. And I have to say, and usually I'll try to do at least one big salad a week, that there's like another energy component that I feel from, I don't know if it's the phytonutrients or what's going on exactly, but it just kicks something in. So Wade, I mean, maybe talk about your gas salad strategy.
Yeah, I'd like to hear that. I mean, I'll add this real quick. Because there's a lot of people are carnivore now and they do one or the other, but if you put your meat, if you eat it with a salad, the fiber from the salad will delay gastric absorption and also is aiding your gut microbiome, especially if you have a diverse array of things in the salad. And that's actually it's decreasing your glucose and insulin response to the protein. But I also think it's promoting, healthy digestion, optimal gut microbiome. So I'm just kind of throwing that out there because I don't know. I just posted something recently and someone said I'm killing myself by eating plants or something like that because plants are trying to kill you. So it's like,
I find that's a pretty extreme position.
Yeah.
That some people have adapted conveniently. Like, wow, I didn't know my salad was so dangerous. But, yeah, I've been a big proponent of, there's a certain, when I go to obviously Whole Foods and things like that, the salad bar, especially when I'm on the road, that's my first stop. And there's there's two things that I think are anecdotally interesting. One is I notice there at different times, I'll be attracted to different colors. And I always indicate, to me, there's some sort of mechanism that's letting me know that I need to get more beets today, or I need to get more cabbage, or whatever it happens to be. So I always find it interesting about the colors. The second thing that I've noticed is, without a doubt, and I'll be going to Whole Foods right after this call, invariably I make these giant salads. Like I get the big green bowls at the Whole Foods that they have them, and it's piled up and it's $30 or whatever for my salad. And every single time, somebody in the lineup or the cashier will comment and say, that looks amazing. And I find that's a very interesting response, that it's so across the board that there seems to be some sort of internal recognition that that's good or that's healthy or that's something that I'd like to try, because it's obviously a ridiculous salad. But I think there was a good point you brought up, was the fiber relation to insulin response or the use of fats. And I believe it's one of the reasons why I have such a great insulin response, despite the fact that I'm on a plant-based diet. I eat a ton of carbs, yet when you do my testing, it's like, it looks like I'm on a ketogenic diet from a insulin response. Any other comments on that from your work?
Well, it doesn't surprise me. I mean, all those vegetables are carbohydrates, right? So you would expect an increase in glucose. But if you have a steak and then you have that same steak with a big salad, you will have less of a glycemic response and less of a rise in insulin too, because it's the fiber is delaying gastric absorption to some extent and just delaying the breakdown and release of amino acids into the blood. And I think it's even more pronounced if you add fat to that salad. I actually think of, in ketogenic diet formulation, the vegetables are a fat delivery vehicle. So you could lightly steam vegetables, saute them, and then add a lot of fat to that. Or a salad, you can add a significant amount of fat to that. You can add, avocados and nuts and olive oil or a mixed oil dressing, and then deliver in a relatively small salad. You could deliver 50 or 60 grams of fat. So that's important clinically, and these approaches are now being used in modified ketogenic diets that are having better outcomes as far as seizure controls or metabolic management of particular disorders. And it kind of goes against what was traditionally that the carbohydrates need to be below the certain level. You're adding a lot more carbohydrates in the form of these essentially non-glycemic fats, but the fiber and the phytonutrients and other factors are greatly helping to actually induce and sustain ketosis. And you're actually probably significantly enhancing the nutritional status of that patient too, by not, eliminating plants, which some ketogenic diets do, but actually being very liberal with your plants consumption, which I think as our nutrition evolves, we need to start incorporating more plants into ketogenic diets.
One note on the
sounds like there might be an actual unification between the ketogenic people and the plant-based diet, which
I'm pushing for it. But
Wade and I are all about that.
Yeah, I'm on that train because we're just into optimal. What is the optimal diet for any given person in any given lifestyle and something they can sustain? So yeah, great to hear that you're on the bleeding edge of that.
Speaking of optimal diets, I mean, one thing I'll share is I optimize my salad using Viome data. So the Viome data is a gut test, and you can send them a stool sample, and it tells you which foods you should eat a lot of, which foods you should eat less of. So I decided, I'm going to build like a super salad kind of just with the foods that it's saying I should eat a lot of. So for an example, watercress, arugula, those came up because I guess I have the gut biome that breaks those foods down. So what was really fascinating was, despite eating like 2 pounds of it, almost sounds about 2 pounds, I would just incinerate it. Like almost nothing would come out. And like even my weight would go down. It almost defied science in the sense that it's like, okay, I'm eating 2 pounds, almost nothing's coming out, and my weight would drop. But if we look at it from a gut biome perspective, where they're eating I'm feeding all the bacteria that I have, and they're just devouring that food, then it does make sense. So I just wanted to share that anecdotal story because it kind of surprised me significantly. To shift gears here, to talk about a subject that I think is near and dear to all of our hearts, which is cancer. I lost one of my best friends, and recently an aunt and an uncle. And I'd like Wade to share his story. about his experience with this. And then I'd love to get into what you've seen as far as ketosis, ketones, and cancer. But Wade, why don't you share your story?
Yeah. So, for those who don't know, my sister died at the age of 22. She got sick with Hodgkin's disease, a form of lymphatic cancer, and progressed over 4 years when I was young. It had a big impact, got me into kind of physiology and exercise and performance. And I've been graced now to actually serve as an advisor for the American Anti-Cancer Institute. And we help people who are either going through cancer or recovering from cancer to make better nutritional selections and to prevent it in the future or to optimize their diet. So it's something I'm really, really passionate about. And I'm curious what you have kind of revealed, because I think one of the things you talk about is the death of cancer, or the powerful effects about the ketogenic diet and its relation to the cancer prevention, or even as an augmentation. What's kind of fueled that, and what have you learned, and how can people who may be in one of those situations, where would they go and how would they start researching them for themselves to kind of create the best survival situation for them?
Mm-hmm. Yeah, that's well, it's kind of a long story, but I'll make it as short as possible. Some of the technologies that we developed for the Office of Navy Research allowed us to look at a variety of cell lines, and one of them was a glioblastoma, a cancer cell line. And I made two observations. One was that high pressure oxygen killed cancer cells faster than normal healthy cells. And that was because cancer cells have a dysregulation in their mitochondrial function. And if you hyperoxygenate them, they divert more molecular oxygen to superoxide anion, which is the precursor free radical that can go on to other radicals that can basically trigger apoptosis in the cells. So we observed this acutely, and I thought it was interesting, and nobody had observed it before because they didn't have a confocal microscope inside a hyperbaric chamber. So, so this was like, I was curiously interested in that. And also when I grew cancer cells under different substrates, including low glucose or high glucose, in particular high ketones, the ketones suppressed the growth and proliferation of the cancer cell lines I was looking at. So I made two observations studying a military project, which is oxygen and high oxygen, high ketones are bad for cancer cells. So a PhD student came along, and actually this became her PhD project. She's now Dr. Angela Pa. And throughout her PhD studies in the lab, we observed that a ketogenic diet with hyperbaric oxygen therapy given 3 times per week suppressed the growth of cancer in a particularly aggressive form of metastatic cancer, a model of metastatic cancer that we had in the lab. And, you know, so it kind of begs the question, then how does a high-fat ketogenic diet, how does that contribute to suppressing cancer growth and proliferation? And it does it through a number of different pathways. One is that we understand now, we actually did back, you know, in the 1920s and 30s, that cancer growth is primarily fueled by glucose. And cancer cells preferentially use a higher consumption of glucose than normal healthy cells do. And we can use a fluorodeoxyglucose PET scan. Oncologists use a PET scan to image the location and aggressiveness of cancer, but they don't really use that information to target the cancer. But we can show through our best imaging techniques that there are consumption of glucose 100 times higher in certain cancers relative to the healthy tissue that's surrounding it. So it's outcompeting the healthy tissue to get the glucose. So a ketogenic diet restricts glucose availability to some extent, right? We know baseline glucose doesn't change all that much unless calories are restricted. But when you eat a ketogenic diet, there is a very minimal increase in blood glucose and insulin. When you eat a carbohydrate-based diet, there's a relatively high spike in glucose and insulin. Those spikes in glucose and insulin are abolished, if not significantly attenuated, on a ketogenic diet. So I think that's important. And really what's important is the suppression of the hormone insulin. That's how actually we make ketones. The ketogenic diet works by suppressing the hormone insulin, maybe slightly increasing glucagon, and that accelerates fatty acid oxidation in the liver. And that continual suppression of the hormone insulin is absolutely necessary for us to stay in a state of ketosis. Cancer cells their growth is driven by insulin, IGF-1, the PI3 kinase, AKT, mTOR pathway, and a few other things related to that. So what the ketogenic diet does is suppress insulin and insulin signaling. IGF-1 goes down, PI3 kinase, AKT, mTOR, that whole pathway is acutely and continually suppressed if you follow a ketogenic diet. So what that does is it takes the foot off the gas pedal of cancer growth. Most cancers are driven in growth and proliferation by this particular pathway, and that's why pharmaceutical companies are scrambling to develop drugs that target mTOR, PI3 kinase, IGF-1, things like that. So that the ketogenic diet does that naturally, as does fasting, but that can't be sustained. So what you do is create a scenario where you slow down cancer growth. The ketogenic diet is not going to cure cancer. So that's really important. But what you do is in some people it has actually, so I should kind of stop, and there's anecdotal reports and even case reports. But most importantly, it will slow cancer growth and make cancer a more vulnerable target for other modalities. And those modalities could be chemotherapy, it could be radiation. We know from clinical data that chemo and radiation can be life-saving for many people. There are things like advanced brain cancer and metastatic cancer where these things do not offer much of an advantage, but in the context of a ketogenic diet, you may sensitize the tumor in a way or make it more vulnerable to make the cancer or the tumor, solid tumor, more sensitive to these modalities. And also immune-based therapies too may work better in the context of a ketogenic diet where you are limiting glucose availability. So essentially what that's doing, it's suppressing the glycolytic pathway. That's how cancer cells are primarily making energy, off glutamine and glucose. When cancer cells do that, it activates a particular pathway called the pentose phosphate pathway. And that pathway generates reduced glutathione. And that reduced glutathione makes that cell like a supercell. It can protect it against chemo and radiation because it's an endogenous antioxidant. If you inhibit the glycolytic pathway, you could do it with a ketogenic diet. There are now drugs that inhibit glycolytic pathways. You cripple the cancer cell's ability to defend itself by virtue of suppressing reduced glutathione. And so now that cancer cell becomes a more vulnerable target, especially to modalities that kill cancer cells through an oxidative stress mechanism. And that could be various chemo drugs and also radiation. So I'm trying to keep it as simple as possible, but I think that the thing is that the ketogenic diet works through many different ways. I just described a metabolic way, but it also functions at suppressing inflammation, which is a major driver of cancer. And then the ketone bodies themselves are epigenetic regulators by acting as class 1 and class 2 histone deacetylase inhibitors. So that's an intense area of focus now in our lab and other labs, as ketones functioning as signaling molecules, even hormones, if you like, in ways that have anti-cancer effects by activating tumor suppressors and actually turning off or turning down oncogenic drivers. So that's an area of intense interest right now, that ketones functioning independent of metabolism as influencing various anti-inflammatory pathways, NF-kappa B, NLRP3, inflammasome, but also through epigenetic regulation.
I'm going to steal a question from Tim Ferriss and see if your answer is different today, which is if you or a loved one had cancer, what would you do?
Find out what all the options are, given the type of cancer. If it's an option where, or if it's a type of cancer where the options are very limited, in regards to the standard of care not being very efficacious. And if it's minimally efficacious, you have to evaluate the patient, with their doctor, whether it's worth doing that, right? So I guess the simplest thing to do is to use what's called the glucose ketone index. So we know if we can, normal glucose being 5 millimolar, say if we could bring our glucose down to say 3 millimolar and elevate our ketones to 3 millimolar, that would give us a glucose ketone index of 1. So if our glucose stays at 4 millimolar and we get our ketones only at 2 millimolar, that would give us a glucose ketone index of 2. If you can maintain a glucose ketone index of 1 to 2, even 1 to 4, normal American is like 25, right? So if we can bring that down from 25, which is a glucose dominant metabolism, to a glucose ketone index between 1 and 4, again, which is glucose over ketones in millimolar concentrations. And in America, we use milligrams per deciliter for some reason, but in millimolar concentrations. So get a GKI of 1 to 4, and that will slow cancer growth, right? I think that's incredibly important. Evaluate the potential for drugs like metformin. Metformin is available. You could jump online and probably get it. Metformin is, when we started studying metformin, there was maybe 2 or 3 clinical trials. Now there's about 200 clinical trials looking at the drug metformin as a means to enhance other cancer therapies. If you have, type 2 diabetes, we know that it knocks down your chances of getting pancreatic cancer in type 2 diabetes population, at least by like 50%.
So how's what's the pathway? Because I've been using metformin now for a few months. What's the pathway that metformin works on cancer?
Yeah, so that's another area of intense investigation. My PhD student studied it, and we know that it actually impairs the complex 1 of the mitochondria, which actually triggers more oxidative stress in the cell, and it may be partial to stimulating more oxidative stress in cancer cells, which could trigger apoptosis potentially. But without a doubt, like it works by probably suppressing the hormone insulin to some extent and knocking down AMP kinase, maybe suppressing mTOR. I think it works not just through one mechanism, but it is an interesting drug that it probably works through several mechanisms in synergy. It probably also has, at higher doses, a mild calorie restriction effect because people who take it tend to reduce their appetite a little bit. They lose a little bit of weight. Some people, there's speculation that it influences the gut microbiome. But it does seem to mimic many of the metabolic aspects of the ketogenic diet. So metformin, I think a patient could add that in, titrate it to a dose that's tolerable to them, which is somewhere usually between 1,000 milligrams to 2,500 milligrams, and then maintain that glucose ketone index. That could be done with a combination of intermittent fasting, well-formulated ketogenic diet, and potentially ketone supplementation. So that's 3 different ways to achieve that glucose ketone index. And exercise is critically important, right? So maintaining your metabolic machinery, but your skeletal muscle. So resistance training combined with, low to moderate intensity cardiovascular training too, that can help sort of optimize your metabolism. It's not one or the other. I think both forms of exercise are really important. Getting outside, natural light, I think is really key. Getting light in the morning resets your circadian rhythm, getting activity throughout the day. Sleep, optimizing your sleep is probably incredibly important. Biofeedback, meditation, your faith, people, relationships, sort of that. So all these things I would categorize as press. And now we can talk about therapies that would be pulse. So all the press therapies create an environment to slow down or stop cancer growth. And the pulse therapies are things that can help sort of eradicate or slowly attack the tumor. And that could be chemotherapy, radiation, immune-based therapies, standard of care. We tend to focus on things that are more non-toxic. So hyperbaric oxygen therapy by itself does not have an impressive anti-cancer effect, if at all. But in the context of the things that I just talked about, then that can make the tumor vulnerable to hyperoxygenation. So hyperbaric oxygen therapy reverses tumor hypoxia, at least when you're giving it, and that can kick on tumor suppressors and actually deactivate oncogenes. And if given 3 days per week, Monday, Wednesday, Friday, 1 hour at 2.5 atmospheres of oxygen, we have found experimentally that works in animal models. The translation to humans, that's my best guess that would work. I don't think it needs to be done 5 days a week as they use it for wound healing. I think Monday, Wednesday, Friday. I think that day off in between for the adaptation is necessary. Another thing is intravenous vitamin C. I don't want to come off as a quack saying that IV vitamin C works, but there are peer-reviewed scientific publications and registered clinical trials right now showing that vitamin C can enhance different cancer therapies, particularly chemo, radiation, I think maybe, and maybe some immune-based therapies too. Vitamin C, if given in high concentrations as an IV, increases, vitamin C then becomes a pro-oxidant at a very high level. It's an antioxidant at lower levels. At a high level, it becomes a pro-oxidant and can drive things like the Fenton reaction, which can actually increase oxidative stress in cancer cells, especially cells that have like a high turnover where you're releasing a lot of heme. And in the presence of heme iron and oxygen, vitamin C becomes a pro-oxidant that can have a very powerful anti-cancer effect, but only in combination with these other things.
What would constitute a high concentration? And is it like whole vitamin C or just ascorbic acid?
Ascorbic. People have used different. Yeah, ascorbic acid would be not oral vitamin C.
Right.
So
Yeah.
Not.
Yeah. I understand it. Yeah.
Yeah.
What kind of dosages are we talking about here on the vitamin C though?
So typically you have to get your blood levels like towards a millimolar concentration. And at that concentration, so that would be anywhere between 25 grams. And I just met with a doctor that was using like 150 grams, but I think usually about 50 grams is going to be a lot. And when you get vitamin C up to that, millimolar concentration, it's functioning as a glucose antagonist, right? So the vitamin C uses the same transporter as glucose, and it's sort of blocking the transporter. Not only is it blocking the transporter and kind of restricting glucose availability to the cell, but as vitamin C gets into the cell, it's imparting that pro-oxidant effect. But anywhere between 25 to maybe 75 grams, I think would be safe. Anything higher than that, I'm not sure is safe. But I personally had 50 grams, I think, and it's just some interesting effects from that.
What else?
I mean, I was just using it, just to test it, to see what it felt like when you get vitamin C. One of the issues is when you do get it, you have to like pee shortly after you do these IVs. So a lot of people ask, should we do it right before a hyperbaric chamber? And it's hard to do that because you don't want to get in a chamber for your session. So.
Yeah.
What else would you add as far as pulse?
Yeah. Well, there's a lot of experimental drugs that are coming online now that are targeting cancer metabolism. So, they've been around for a while. One is 2-deoxyglucose, and that's actually used. It's a glucose analog that blocks glycolysis, and it's being used experimentally as a ketogenic diet in a pill for epilepsy, and I think in some cancer trials now. It might be like phase 3 cancer trials. So that's 2-deoxyglucose. There's 3-bromopyruvate, which is a bit controversial. The drug Tripping Over the Truth talks about this molecule and the history behind it at Johns Hopkins. So now I believe, it's in clinical trials. It's also a glycolytic inhibitor. Lonidamine is one. And then Lou Cantley, Cornell has sort of developed a company that's developing these PI3 kinase inhibitors. And he's published some work on it. And interestingly, the PI3 kinase inhibitors, and it's a little complex, it influences counter-regulatory mechanisms that actually elevate insulin. And that can be, that can negate the effects of the drug, the anti-cancer effects. But what he found is that when the PI3 kinase inhibitors are combined with a ketogenic diet, that sort of the ketogenic diet, that thereby suppressing the hormone insulin. Under conditions of insulin suppression with the ketogenic diet, PI3 kinase inhibitors are remarkably effective, and they may be the most important class of chemo, or I wouldn't call them chemo drugs, cancer targeting drugs that we have on the market. And I think it's interesting that they work really only in the context of a low carb ketogenic diet. So I think, you have to look at the clinicaltrials.gov lists what clinical trials are ongoing. And I don't know now if that's going to be available to patients, but it's being tracked in that direction.
I think one of the exciting things that you're actually eliciting here is the role of solving, addressing dietary components as a methodology to, accelerate or advance maybe drug treatments that someone would be doing in that case. And that's an area that I'm very passionate about, because I think what happens is with the typical cancer patient, it's like they focus all on the drug stuff, but almost nothing on the lifestyle. You have people in the holistic thing that's focusing almost completely on the lifestyle stuff, and not on the drugs. And I think really both people would benefit from sharing their information, data, and patterns to create a more holistic and unified approach from, when you're in a cancer challenge. I mean, it's a life and death situation. You want to bring every resource you can to the table. And I think it's great. I salute the fact that you're bringing attention to that, especially in the circles that, for a lot of cases, avoid those conversations around diet with the kind of the negative nutritional training that medical doctors have, which just blows me away. These very accomplished, very intelligent people, and there's no attention to diet in regards to people's cancer treatment, which to me seems completely insane.
The diet, or even all the, things like hyperbaric chambers, and biohacking, and all the things that we do. So I mean, as guys coming from the bodybuilding universe, we all know the power of stacking. Bringing that mindset, that strategy to me, to any health problem, I think you're going to achieve far more success than trying to just have one single-minded approach. Just like they do in Las Vegas, you want to stack the odds in your favor and just do every possible advantage. So,
yeah, it makes sense. If you take a multifaceted approach, then you don't have to use an astronomically high dose for a particular agent, right? Because you can use many things synergized together, so that and many things can counter regulate some of the side effects, like if you employ the ketogenic diet, that greatly reduces the side effects of some chemotherapeutic agents. And we know by Walter Longo's work, and at least a half dozen publications now, fasting prior to chemo can dramatically decrease the nausea, the side effects, even the pro-inflammatory, storm that the body has, that attacks your healthy tissue. So when you fast, and I don't advocate fasting loosely. It needs to be done under, really tight conditions. But you can mimic it with a ketogenic diet. When you do that, that's really setting the stage for these other therapies to work better. I mean, you're making the tumor more sensitive to that modality by crippling its antioxidant capacity. But you also may be sort of upregulating some of the transporters too, may take up more of the drug. So investigators are looking at that too. So you may be like sort of saturating the tumor if you deliver a drug in a site-specific way when in a fasting state. So that needs to be appreciated too.
And as you're a wealth of knowledge, and we could probably keep going for at least another 12 hours before we ran out of questions. We'd love to probably have you back as a guest in the relatively near future. Wade, any final comments before we wrap up?
Yeah, I guess the big thing is where do you see the future of this going, Dominic, with your research? And then I know you're kind of dealing with kind of extreme conditions with, health challenges and also, security force type of stuff, people in extreme conditions. Where do you see this going, and how do you see this kind of spiraling down to the general population or people who are certainly on the cutting edge or of biohacking or biological optimization, which is what we're into, is how do we optimize the biology for the performance that we want to get? What do you see happening in the next, say, 5, 10, 20 years?
Well, I think it will, and I hope it will continue to explode. I mean, in 2008, it was a little blip on Google and a little blip on PubMed, and then there was an explosion of the research. And I think the actual peer-reviewed research was driving interest in these ketogenic diets. And I think it helps to have, podcast celebrities like you guys and Tim Ferriss and other people have sort of helped sort of cross-promote it in different ways. But I think the science, as it's emerging now, and there's a lot of studies in progress, will drive interest and sort of legitimize the diet, not just for epilepsy, but all these emerging applications. And you have athletes in the field, you have people like Jeff Bolick and Steve Finney studying it for athletics, even strength training too, studies are being done. I think people will see it as an important tool that can be used continuously, if not intermittently. Maybe I think intermittent use of the ketogenic diet in a normal healthy person has so many benefits. And even I think our military personnel, we have a weight problem in the military, and even, type 2 diabetes problem. And I think that can be addressed with low carbohydrate nutrition. I think our nutrition is really favoring processed carbohydrates and sugars, and that's contributing to the problem. So I think first and foremost, it's appreciation that our bodies can be fueled off fat and ketones in a healthy way, and that we need to minimize and start to decrease sugar and processed carbohydrates. And also this idea that a ketogenic diet is not necessarily just bacon and eggs and lard or dairy, high dairy fat, that it can be rich in fibrous vegetables and rich in phytonutrients and things like that. So the advancement and the evolution of ketogenic diets changing from highly restrictive diets to diets that can be formulated and engineered in ways that optimize our nutritional status, our phytonutrients, and the sort of knowledge we get on the different types of fats and different protein sources will all be incorporated into the knowledge of ketogenic diets, and they can be formulated and even customized and personalized to the patient, perhaps even based on their genetic profile.
Real quick on that, one segment of that, I'd like to kind of just as a someone who's saying, hey, I'd like to do the ketogenic diet, I want to follow regularly, intermittently or periodically. What do you think would be the beneficial time? Like how long does say someone like myself, if I'm following my typical diet, if I move to a ketogenic diet, say on a per annual basis, how long do you think that duration should be in order to elicit the benefits? And then how frequently would I kind of draw back to that?
Yeah, that's a good question. I think some of the, Walter Longo has this fasting modified diet, and the idea is to do it for 5 days out of the month, where it's a calorie restricted diet that sort of puts you in a state of ketosis, but is more of a plant derived, it's powders and stuff all mixed together. But I think one can achieve many of the metabolic benefits, the anti-cancer benefits, and sort of the autophagy benefits by employing nutritional ketosis for just 3 to 5 days per month. And it doesn't have to be fasting. I think they could just knock their calories down to maybe 500 calories a day and just do a calorie restricted, well-formulated ketogenic diet, which could be a salad with some fish in it, and phytonutrients, olive oils, things like that, and just have that as a single meal, 1 day per week for 5 weeks, and just moderate the calories to like 500 calories. And then towards the end of that week, you'll accumulate a significant calorie deficit that will trigger many of the the signaling and metabolic pathways that we know are associated with many of these benefits, including, activating autophagy, activating anti-cancer pathways that could potentially help purge our bodies of precancerous cells and also stimulate and maybe revive our immune system too.
That's great. Matt, you got any other words you'd like to throw in here?
No, but where can people kind of keep up to date? What's your social media handles?
Yeah, I think I never know them offhand, but I think I said that too. But the one-stop shop, like for all our information, would be ketonutrition.org. So all one word, keto nutrition and .org. We have a blog and we post like once every 2 weeks or so, and we don't sell any products, but we have products on there that we like and we support and that we've tested. And we have, I have my podcast on there. I have scientific publications, stuff like that. So, and you can also email us through that if you have any questions too. And I try to handle as many as I can.
Dom, you are a wealth of information, and we were excited to do this interview. We're excited to bring you back because every time you answer a question, it just triggers off another array in my own mind, and I can see Matt kind of lit up the same way. So hopefully we'll get you back really soon. I also want to thank you for doing the work that you're doing. I think you're providing an extraordinary service to mankind, and thankfully through podcasts and this kind of dispersion of information, you're providing options and opportunities for people who may not have access to this information, but could actually save their life or certainly let them live at a higher quality of living. So thank you for that. We can't wait to publish out. I know you'll probably get a lot of questions and stuff. We will put everything in the show notes, all of the points that you brought forth. And if anything else comes up, let us know. We'll be happy to do that. I guess in closing, I want to thank everybody for joining us today on this podcast. Check out Dom's stuff. It's fascinating. Go to his website, ketonutrition.org. It's been a great podcast. Thank you, Matt. Thank you, Dom, for joining us today. It's another day in awesome health world. And so happy to have you here and keep the message flowing.
At Bioptimizers, our mission is to fix digestion. And a cornerstone of digestion is gut flora. P3OM is our patented probiotic formula. In fact, we call it the Navy SEALs of probiotics. You see, strong proteolytic or protein digesting activity is paramount to having a healthy gut flora. And of course, P3OM provides that. The good news is, unlike weaker probiotics, P3OM survives the digestion process. What it does is it basically multiplies the good guys while protecting you against pathogens, or what some people call the bad guys. P3OM really helps to rebuild your digestion. And what that allows you to do is to maximize nutrient uptake, energy, and metabolism. To find out more of how P3OM can help you, go to www.bioptimizers.com.
Thank you for listening to the Bioptimizers Awesome Health Podcast. You can find more information at bioptimizers.com.